Real quick, I'm going to show you two different situations in where we would need to multiply polynomials. And before we even get into those two situations, let's just review our rules for multiplying here. So I know if I have the term 4 and I multiply that by x, that would be 4x, right? And if I have x times x, I guess this is really our first time seeing this, but x times x gives us x squared. Why does that work? Well, because if two numbers have the same base and you multiply them, you add their exponents. And you'll say, Mr. Woodell, they don't have exponents. Well, remember, if they don't have exponents, they're ones. X to the first power is just x. So because they have the same base, x to the first times x to the first gets us x to the 1 plus 1. I'm adding the exponents, which is just x squared. That would work for any power of x. I guess I could have made it over here, but if I had like x to the 4th times x to the 3rd, well, that's really going to be x to the 4 plus 3, which is x to the 7th. So now that we've cleared that up, let's talk about multiplying these polynomials over here. This looks like the distributive property problem. So what I will do is take the entire first term right here and multiply it to both of the things inside the parentheses, which gets me 6v times 2v plus 6v times 3. So let's use what we just talked about over here to see if we can clear up some of this multiplication. I'm going to first multiply my coefficients. 6 times 2 is 12. And v times v, like we kind of saw over here, remember the exponents are ones, would be v to the 2nd power. 1 plus 1 is 2. And then over here, I'll multiply my coefficients again. 6 times 3 is 18. And it's a little weird to think about, but there is an imaginary v over here. We would think of it as z to the v to the 0 power, but it's still over here. So if I add my exponents here, we get v to the 1st, which I'm just going to erase because it's just v. But that's one way to kind of think through our multiplication. But one of the more common ways you'll see is if we multiply these binomials, and I guess I'll write that over here. So the prefix bi means two, binomials. So I have two terms that both have two terms inside of it. So let's see what happens. This is almost exactly like the distributive property problem over here, except there are now two terms in front of the parentheses. So what I'm going to do is I'm going to take my first term and multiply it to the things that are inside the parentheses. And I also have to take the second term and multiply that to everything inside the parentheses. So I end up with 4 different terms that I may or may not have to combine to simplify. But let's start by doing 2n times 6n plus 2n times 1. So I got my 2n multiplied to both of the things on the inside, switch pens. Now I have 2 times 6n. And then finally 2 times 1. Using our rules for multiplying, 2n times 6n is 12n squared, plus, well, 2n times 1 is just 2n. And 2 times 6n is 12n, and 2 times 1 is just 1. Or sorry, just 2. This is 2n. I don't know if I said that correctly or not. And here, it looks like I can combine some like terms to get my final polynomial of 12n squared plus 14n. Oh, this should be plus 2. Oops, this should be plus 2. Plus 2. Very cool.